let's look at our agenda. We're going to start off by talking about Wayfair's decoupling journey, how we went from a great big monolith into thousands of microservices. And then we'll take a look at the problem that created in service discovery. And then we'll talk about how we solved it using Backstage and OpenAPI. And finally, we'll get into some of the lessons that we learned along the way, because of course, every solution has its own set of problems. And then we'll kind of talk about our next steps with this area of work. So my name is Shai Sachs. I'm a staff engineer on the service-to-service platform team. Currently, I'm designing a governance layer for our microservices. My career has been just chock full of APIs for some reason or another. I tend to live and breathe like really weird Bash and JQ scripts, for better or for worse. Love bicycling, love reading, and it's been a great time. I've been here at Wayfair 2.5 years.
Hey everyone, I'm Zoe. I'm an engineer on the developer experience team. I've also been with Wayfair 2.5 years, like Shai, and I'm working on Backstage at Wayfair. That's the go-to place for discovering services, creating info resources for your services, and executing workflows.
Great, so let's talk a little bit about our history to decoupling. For a long time, Wayfair has been a pretty traditional PHP shop. We have 3,000 some engineers, day in, day out, working on making our e-commerce solutions better. And a huge part of that e-commerce solution is one great big PHP monolith. At one point, I weighed it. It was 3.5 gigabytes of PHP code. And I'm not talking about images or JavaScript files or any of that great stuff. 3.5 gigabytes of pure text PHP code. So it's a great big ball of code, and that creates all of the problems that you'd imagine with developer velocity, and the ability to move quickly and independently from one team to the next. So back about 2019, we realized, look, this monolith is really starting to hold us down. It's making us less nimble. We can't react to market conditions quite as well. We started a journey towards a microservices architecture. We started decoupling our monolith. Now, 3.5 gigs of PHP code don't go away all that easily. And so we really had to work very carefully to do that. We started by onboarding to Google Cloud. We stood up a couple of Kubernetes clusters, and we started creating some paved roads for developers to get from the monolith into new microservices. We chose 4 different languages and platforms to support in the new ecosystem. So alongside PHP, also Python, and particularly Fast API, Java, particularly Spring Boot, and C# 5, .NET 5, excuse me. And then we integrated those language platforms with OpenAPI and Swagger UI. And so the way that worked was pretty interesting. In late 2019, early 2020, we saw kind of like dozens of different people start working on this new paradigm. And we saw some real successes. There were a couple of departments that got out of the gate real fast and put together some really interesting microservices platforms for the rest of the company to use. And momentum really snowballed from there. Today we have hundreds of teams creating thousands of decoupled services, and there's more spinning up every week. We put together some really interesting metrics to measure this evolution and discovered that earlier this year, so about 1.5 years into our microservices journey, earlier this year, we discovered that the average developer experience at Wayfair is entirely outside the monolith. So over 50% of our developers day in, day out are not touching the monolith. And then you have some number who are living in both the decoupled world and the monolith world, of course, but that number is improving every day. So it's very exciting stuff, except for one thing. when you have thousands and thousands of microservices, how do you discover the microservices that you need? So I'll tell you a kind of a hypothetical story that illustrates the kind of thing that we handle here. Let's say my team is responsible for calculating taxes on a product, right? So in order to do that, I need to know, first of all, what's the price on the product. Secondly, what's the tax rate on the product? And maybe I need some other pieces of information, right? So maybe I have a product that's sold in the US, in the UK, and in Germany, and maybe the tax structure in each of those countries is very different. Maybe you have tariffs, maybe you have whatever other things, right? So I need to know, okay, what's the price in each of those three countries? What's the tariff rate? What's the sales tax rate? So on and so forth. Well, now in this microservices world, I need to go and find what the pricing service is. Who is that team? What kind of APIs do they offer? What's the contract? How, at a very concrete, level, how do I write the code to interact with those services? Does the service even exist? And this is really actually a pretty simple problem that I described here, where I only have, one or two dependencies. Some teams have a dozen dependencies or more, and it's not at all clear where should they go. So I'm going to hand this off to Zoe to talk about how we address this problem.
Thanks, Shai. So, in the beginning, before there were like any sort of good process, it was basically engineers asking each other who's working on what. You kind of know, like, or maybe the pricing team might have the service that you're looking for, so you can look through the org chart to find the right team, the relevant teams. You can look through their documentation, read through different like emails and release notes, and you can also search on GitHub for keywords if you're really desperate. So this isn't very like efficient. So what came after is an improvement, which is the Kubernetes catalog, where most of our services are deployed to Kubernetes. So then we're able to build a huge scraper that collected the services and its metadata using the Kubernetes API, GitHub APIs, and our internal APIs. So it was very comprehensive. You knew like which team owned what, where it's deployed to, what Helm chart it used. But it wasn't very usable in the sense that you couldn't, play around with the API right there. You would have to do more digging into what the service actually does. So then it comes Backstage, which is an open source project by Spotify, and it's a general purpose developer portal built using TypeScript and Node.js. And it can have service catalog. It can have different workflows that engineers can run without creating tickets. You can create infrastructure resources right there, like databases or GCS buckets. And it's very extensible and has a lot of different people contributing to the plugin community. So I'll talk about how we brought these OpenAPI services to Backstage to be cataloged. Just to provide more context, I'll take you through like how an engineer would develop like spin up a new project at Wayfair. So they would use Mamba, which is like an internal project generation tool that uses cookie cutter for code templating. So our language platform teams have different templates for like Python, PHP, etc. And this makes it really easy for an engineer to create a project. Then because Mamba will take care of creating the GitHub repo, setting it up correctly, setting up the build pipeline, using the right Kubernetes Helm chart, and your service will be live in minutes. So now that you have this project ready, you'll write some code, and we picked Fast API as an example because it's very popular within Wayfair engineering, and it's the easiest for Backstage for us to find and to put into Backstage. So let's say you're making this Fast API, and in case you're not familiar, you can use these annotations to connect functions and code to routes to fit the OpenAPI specs. So it makes it really easy for an engineer to just worry about what kind of API they're gonna build instead of worrying about like how can I make this like follow the OpenAPI spec. So then let's say you have something to test, and you can generate this locally as well, this Swagger UI, which takes your OpenAPI file and displays it in a pretty way, and you can play around with it. This makes it easy for other people to discover it as well when we put them into Backstage. So how we did that is we like I mentioned before, we deploy most of our services to Kubernetes. So then we can use the Kubernetes Catalog API to find these services that use a specific Fast API Helm chart. And then we build this custom catalog processor for Backstage to ingest these services. We basically provide the location of the OpenAPI files for each service. We check these two common locations. What you see on the right is the component like YAML object that we build out using the Kubernetes catalog. So Backstage then displays these services and the API definitions right there. So it makes it really easy for anyone to search for something. Let's say like, oh, is there a service related to book? And they can search that and find the service and play around with the endpoints without having to leave Backstage. There are 175 and more Fast API pages generated on Backstage, and Backstage auto updates them on a frequent interval. So someone doesn't have to like manually update some file. So now I'll hand it back to Shai to talk more about the learnings.
Great. So Zoe gave you this very nice progression of how we moved from sort of real chaos into service discovery to a really nice, pretty system. But along that way, we discovered a lot of sort of funny questions and had to figure our way through some interesting quandaries. So I want to talk about those right now. It's very well to actually put OpenAPI files in Backstage. The question is, how do you actually generate OpenAPI files in the first place? So we saw a few different practices emerging. One was what we call schema-first generation, and this is where teams will manually generate their OpenAPI files, let's say in text editor, Sublime, what have you. Or some teams will use like an IDE, like Swagger editor. And that's nice up to a point. It has real limitations. Like the developers really need to know the OpenAPI spec, even with an editor like that. And it's certainly easy to botch it up, either syntactically or semantically, in terms of you can misrepresent the operation of your API. Not an easy process. I actually did it once myself a few years ago, and very interesting learning process, but not something I want to do twice. We saw a lot of teams using sort of collaborative text editing to sort of freeform put together their spec. So you'd see, particularly in cases when there are new features being spun up and you have a team producing a new API with an intended consumer team that's going to be the first user of that API. Well, the producer team will spin up a Google Doc and they'll sort of throw together some request and response bodies. Consumer team will take a look at that, annotate it, send along comments, etc. Hopefully you come to an agreement. And that works okay. As a collaborative environment, Google Docs is pretty good. The problem is it's rather error prone. You can wind up creating some unrealistic designs, even have seen invalid request bodies, things like this. And the third paradigm we came to was code first generation. So here we leverage special purpose libraries. For example, .NET has one called Swashbuckle. And the way this works is you write essentially function signatures and stubs, right? As you saw in the earlier code example, like I'm going to write my great big calculator API and take in integer A, integer B, and produce integer C, which is the sum, right? And then Swashbuckle will take a look at my function signature, and from my C# code or from my Python code or what have you, it'll generate OpenAPI file to match, and then Swagger UI can display that for the user. It turns out to be a really nice experience for many reasons. One is that your spec right out of the gate conforms to your code, and it's actually pretty hard to generate a spec that doesn't conform to your code. You can let people play around with it and get a feel for the mechanics straight away. The downside is that it's just that little bit more friction than Google Docs. And even with some really nice paved paths into code first generation, we still see teams playing with Google Docs quite a lot. So, you know, what we learned, I've sort of tipped my hands here. We really sort of dislike schema first generation, and we've seen a real drop in that. So that's exciting. We really like code first generation as a paradigm, but we also discovered like sometimes you have to meet teams where they are. Sometimes I send Google Docs, and that's okay. It's maybe a little bit unideal, but that's how the world works. Second question we had to address is like, where are you going to store all these OpenAPI files? We basically had two competing alternatives. One was in GitHub, and the other is static file repository. In our case, we use Artifactory. GitHub has a certain appeal to it. You put your OpenAPI files there, they're automatically versioned. The change in the OpenAPI file travels with the change in code that corresponds to that change in spec. It's really nice. Big problem is that developers can wind up unintentionally botching their OpenAPI file due to merge conflicts, due to someone fat fingering a text file edit, something like that. The static files are a lot simpler. You have your build kite or your CD process essentially build an OpenAPI file from your code using code first generation, stick it in a static file repository, and then that's it. Nobody can edit it from that point forward. And so as long as you name it nicely, and I provided like a kind of a sample naming scheme here, but you could imagine many other equally good ones. As long as you name it nicely, the correspondence between your OpenAPI file and the code that it corresponds to is sort of locked, and users can play around with it pretty reliably. You do have to do a little bit of gymnastics around feature branches, so that's kind of okay. It's a problem, but a surmountable problem. So we wound up going with API specs and static file storage. So final question we wanted to address is how do we interact with continuous deployment? So a really attractive thing that we thought about is, well, could we actually use continuous deployment to prevent contract breaks? Just by way of review, contract break is a situation where an API producer has some contract with a consumer and they fail to meet it. So in the case of my tax rate API, maybe I'm producing some kind of tax service that tells you the sales tax, the tariff, the 3 or 4 other things. And one day I, fat finger my code and I drop the tariff property, right? So I'm no longer reporting out tariffs in my response objects. That can create a big problem for my consumers, right? Like they are relying on that tariff property maybe, and all of a sudden their code starts to break. And that's definitely not a good situation. And so we thought, well, you could use CD to detect this. You could say, okay, well, we built your API Docs, and we looked in your API Docs, and V2 of your API, or sorry, V1.1 of your API no longer supports tariff. V1.0 did. That's a contract break. You can't deploy to the production. And there is a certain appeal to that. That can actually be really helpful to consumers. The problem is that that can also block rollbacks. So rollbacks can happen when you have some kind of SEV on site, you have some kind of issue, and you need to quickly restore your service to a known good state. Well, a rollback can look an awful lot like a contract break unless you're doing a really, really good job in your CD process. And we wanted to steer very clear of that scenario because rollbacks tend to happen when there's something very time sensitive going on. You have major sales holidays, something that happens at Wayfair, and we need to be very careful around that. You can be losing millions of dollars an hour or something, and all of a sudden you can't actually deploy a rollback, or you can't roll back your code because of this silly CD thing. That's not a state we really want to be in. So for the time being, what we're planning to do is, like, yes, by all means, use unit tests, use functional tests to prevent defects in our API code, make sure our API docs are well linted, etc. But we're not actually going to protect against contract breaks via this particular mechanism. We have other mechanisms for addressing contract breaks, but this is not the one that we thought made the most sense. All right, so I want to talk a little bit about where we're going next. I mentioned that we have 4 supported languages at Wayfair. You probably picked up that currently we're only supporting Python APIs and Backstage, so that leaves a lot of room to grow and improve. We want to support Java, C#, and PHP, our other 3 supported languages. We want to support other types of APIs, like GraphQL, async APIs in the case of Kafka topics, things like that. Just want to give a quick plug. If this kind of problem interests you, I definitely encourage you to take a look at our career portal. Get a hold of me, get a hold of Zoe. By all means, we have a lot of interesting problems, a lot of openings to address those problems. We have offices in Boston, Berlin, Austin, Toronto, and San Francisco, so really all over the world. You're very welcome to come join us and help us tackle these problems. Finally, please do check out this Google form, give us some feedback on how we did. We're always looking to improve, so by all means, get a hold of us. Let us know what we could do better next time. Thank you very much.
Thanks, everyone.
All right, hello. Hopefully this worked. Okay, great. Thank you very much, everyone, for all the interesting chat and Q&A. Hopefully you could tell we pre-recorded that video, which is why I was able to join you in the chat. I wasn't multitasking, although that would have been impressive. So there were some great questions, and I want to try and kind of knock them out in chronological order, I guess, if that's all right. And the first one looks like Vincent Barrett. Apologies if I mispronounced your name. Was do we have some kind of API review process or linting tool to ensure consistency of APIs? Excellent question. So there is a linting tool that we've been playing around with for especially schema-first development for the handful of teams that do that. We play around with Spectral, and I believe I saw there's a good talk on that later this afternoon, so that's worth checking out. For code first generation, linting usually doesn't matter too much in the sense of strict syntax checks. Like if your code first generation creates an invalid schema, you're kind of in trouble. It means the library you're using is pretty bad. But I think more to the point is the semantics of it and the sort of DevX of the APIs. And that is something that we did talk about kind of early in this journey, let's say about 15 months ago, last summer maybe, when a lot of teams were just kind of dipping their toes in the water. And we sort of walked back from that. We kind of declined to implement a really strict governance process, especially on, even on things that are fairly simple, like, country codes or currency codes or things like this. We sort of let it kind of go Wild West. And there's sort of 2 sides of the coin there. One is autonomy for teams. Like nobody in the API community at Wayfair really wanted to be a gatekeeper, and sort of tell teams like, no, you can't do this, no, you can't do that, because you then slow teams down, you become a bottleneck, et cetera, et cetera. Side of it, of course, is that like we now have thousands of microservices, and country codes are sometimes not perfectly aligned. Not the country codes themselves are fine, but like in some places you are using a country code, and some places you're using like a numeric ID, and that's weird, and the DevX is a little strange, and that's an issue that we are going to need to like kind of come around to. But our take was kind of like, let's let people move fast before we kind of do. I know there's a lot of other companies that sort of look at their sway and say like, no, we need good consistency, good DevX, and that is really important. Consistency really matters for like ease of use and reduced friction as teams kind of move from one API to the next. It's just sort of how we landed with the particular challenges that we were facing. So I think there's perfectly valid answers on both sides of like the sort of governance coin, as it were. Yeah. I've been putting like 5 different ways you can communicate country in the chat. Yeah, exactly that. All right, next, Kevin Swiber. How do you handle the ideate design? And sorry, Zoe, did you want to throw anything in there on the governance issue?
I think
Okay.
you covered it well. And then I just want to thank Alan Crosswell too for sharing Django stuff.
Yep.
We can move on to the Q&A page now.
Yeah, so in the Q&A, Kevin Swiber had a question about ideate design prototype loop. So I think we see kind of 2 versions of this, or 2 like sort of angles of attack. One is like the Google Docs approach that I mentioned, and this is like, it's not like me, my personal favorite. It feels a little hacky, but I'm also like kind of touching off that last answer. Like, I'm not going to go tell anyone no. And usually what happens is like we have team A and team B, and they're like coordinating to build a feature, right? And so team A spins up a Google Doc, and team B kind of looks at it, and you go back and forth for hopefully only a couple of days or a week, and then you start building, and you inevitably kind of prototype and iterate. And what I usually tell teams is like, bring your, in that scenario, I say, bring your consumer teams in as soon as you possibly can. Like if you're kind of designing your API with your first consumer team, you're in really good shape, because you have a really good tactile feel for like, how is this API going to behave in the wild? The other flavor that we get is more the code first approach. And with that, I usually say like, put together a route, put together your stubs, right? Like the shape of your response and your request bodies if necessary, and that's it. Throw only that out, right? And you can then, with Swagger UI, you have a working prototype, not working, but like you have a prototype of your API, and people can sort of get the feel for like, oh, okay, this thing is an int, that's a string, blah, blah, blah. And, the sort of downside of that is like you don't have a natural commenting interface. And so that has to go kind of behind the scenes in Slack. So it's a rough edge that I would love to see improved on. I know we're running a little low on time. There's a question about have you found it easy to change your mind having pursued code first design paradigm? Which I think kind of comes back to that ideating thing. Yes, I think we definitely do find sometimes that like, oh, we kind of got it wrong on the first cut of the design, and you need to like either V2 it or like carefully deprecate. We're kind of experimenting with this thing called PACT. It's like an API testing, contract first testing paradigm that allows you to break contract a little bit more assertively and a little bit more cooperatively with consumer teams. That makes good sense in like a microservices context and less sense in like a public API context. But like, that's early days, and all I can say is hopefully next year I'll be able to give a talk on Pact. But changing your mind is always difficult, unfortunately. Okay, hopefully I answered people's questions in time for, good, we have some Pact fans. Yeah, compare API specs. Yeah, Vincent, I think you're talking about Pact there. Cool. I think we're almost at time here. Thank you everyone for showing up. I hope we answered your questions as well as possible. And hope to see y'all around. Definitely get in touch with me or Zoe if you have any questions, or certainly if you want to look at jobs at Wayfair. We're very happy to have you.
Also hiring JavaScript engineers as well.
Yes.
Bye.
All right. Bye everyone.